we are going to have some fun with Dagger modules. So yeah, in the menu today, there is taking a look at how you can automatize tests for your application that runs on Kubernetes. We have a Kubernetes cluster, your awesome tool that runs something. So you have here your awesome tool, and you want to install this. You have some recipe to install this on Kubernetes. Yeah, and most probably you have one of the way you want to install this is an Helm chart. Let's pretend for a second that you have an Helm chart for your tool and you want to verify each time you do a pull request or each time you are developing something that this installation process won't break, okay? So the idea is that you want some kind of tools here at this level, so at the level of your repository, you want to put in place some tests, right? That can be end-to-end test, or I don't know, some kind of integration with other tools, and so on and so forth. So you want to integrate these tests on a continuous integration pipeline, like, I don't know, GitHub Actions, or or you want to, but yeah, let me go ahead. Okay. So with the very same kind of tool, you want also to be able to run your local tests. Okay, so because this is the part that is needed for development, right? So if you want to develop, you want to firstly load and test your code locally, and then push this in a remote repository. And usually what happens is that your local test environment is different from this one. So this is the problem so far. We want to see if Dagger is able to face this issue. Okay, starting from the requirements. We need just two elements for this demo. That is a Docker engine running and Dagger command line installed. So once we have these two, we need Docker in this environment because this will be the engine, the backend engine, where all our pipelines will be executed. Dagger, in fact, is a runtime that is running inside Docker, but it sets up its own runtime. So inside here, that is the Dagger runtime. Inside here, you will have all your blocks or your pipelines that will do different stuff. We will see in a minute what it is. But the added value of this approach is that these kind of pipelines will be the same either on your laptop or your PC or on any CI tool, right? These blocks here can be reused. So the other concept that I want you to have clear in mind is that whenever I talk about a module, so if this is a module, you should imagine like a Lego block that you can reuse and compose with any other modules in any other supported language. So we are going to use Go, but you can also write your pipeline in Python. And in this channel, we already see some example of Python pipelines. So the first concept is module. And a module, in the case of Go, but also in Python, is you can imagine like a struct with different methods. So you have method 1, method 1, 2, 3, and 4, and whatever. We are going to see two different approaches. For test, you can imagine to implement just the bare minimum methods to install all your requirements, meaning a Kubernetes cluster in this runtime and all the function for installation of your tool and testing it. But then there is a concept in Dagger that we are going to look at briefly that is called chaining. Okay, so you can chain different methods, so you can compose kind of different behavior, chaining method 1 with 2 and 3, or method 1 with 3, and so on. This is not fundamental for the testing phase, but it's very important if you want to go further. If you want to leverage this runtime in isolation to run, to make, let's say, a suite for your developers, for your contributors to get started quickly in the development phase. Meaning, okay, I provide you a module to install everything, and you can start from there to develop stuff. So you can either test or start developing in a complete environment. And the module are collected in what is called a Daggerverse. So if you go to the daggerverse.dev web page, you can search for all the community modules that are already present. One of these is the Marcos K3S module. And in fact, you see that here you have all the needed stuff to get started to bootstrap a Kubernetes cluster on your runtime. So meaning that forget about having dedicated pipelines, dedicated GitHub workflows to bring up your K3S cluster. You will be able to instantiate a K3S cluster in the same manner, either you are on your laptop or on your GitHub Actions. And the other part that we are going to need is, okay, how I can take this module and compose this with my test suite. That can be, I don't know, maybe this second module. So let's jump to a terminal and set up our environment. Okay, I created an empty folder here that is called K3S in Dagger, and right, and then we have, first of all, to create a directory called charts where we're going to put our demo Elm, and our demo Elm would be installed like Elm with the default chart that is created by Elm create. So Elm create charts Elm create -h. I always forget. Okay, create name. Okay, let's jump into charts and let's create Elm create awesome. Okay, so now inside charts we have the awesome folder that is containing the default Elm chart, and so this is our application that we want to test. And in particular, you can see that awesome in template is already have a test suite, a simple connection to the instantiated services. So via busybox container, you do wget, you see if everything works. So let's suppose that this is the test that we want to run. Okay, it's pretty simple, it's artificial, but it's good enough to check the whole chain. So then let's go back into our K3S in Dagger folder, and let's instantiate our Dagger tool. Okay, so it's simple, like you see first of all that I have Docker running, and here is the runtime in Dagger. But yeah, so let's instantiate Dagger init, and again, I never remember it's done. So Docker init, we need a name for our module, so we are going to take a name for this module that is well, demo SciGex. Okay, and then the SDK that we're going to use in this example is in Go, but you can use Python, whatever. You can find in the documentation all the equivalent of what we are doing. And then the source code for this, we are going to put it to a directory that is called CI. So if we create this, it will take just a few seconds, and we instantiate all the needed part of the SDK to get started. So with a default module that we are going to edit. Okay, so it's making files, directories, Docker JSON, so it's instantiating everything. And then, all right, cool. So now we are almost there. In fact, if we check, okay, I have not reinstantiated here, but if we go and check inside CI, we have the default implementation of a Dagger module. Let's take a look. So we have a Dagger JSON. Whoa. Okay, Dagger JSON with the engine version and all the details. And then we have our main.go. This is the only thing that you need to look at least when you're starting. This is a demo implementation of a module. So let me close here. And as you can see, your module is a struct with different method implemented already. These are demo. We are going to get rid of all of them to instantiate what we need. Okay, so let's start from scratch. And okay, cool. So save. But before going ahead, we need to develop our plugin. So in order to do this, you need two things. First of all, we need to install the only dependency that we are going to need. And the dependency is the Dagger module that will allow us to install the K3s inside Dagger. So if we go here, we're going to install a little older version because it will work best with our current Dagger engine version. And yeah, so we are going to install the 0.6 version. So here we are instantiating like this. Okay, we are instantiating our modules, and then we are setting the Go mod content to be able to have a complete IDE setup. So we have suggestions for modules and methods as we go. All right. Cool, so we have our modules and now we just need Dagger develop to set up everything from the beginning to the end for our IDE. I use Vim, but it is the same for any kind of IDE you want to use. All right. So I passed in the chat here okay, since I think someone can be interested. Both the link to the module that we are going to use, and also later I put in the description the reference to the demo that Marcos has had at the community call. But yeah, so far so good. We have installed our dependencies, we have done Dagger develops, so we are ready to do mvim ci main.go. All right, so now it's time to take our next step into our module. And let me just go back briefly, very briefly, I promise, into our sketch here. So let's move to a new folder to illustrate what we need to implement. Very briefly, don't freak out. So we need a new method, so a method called new to, that is our init function, okay, where we instantiate and we give a name to our instance. Then we have a create cluster, okay, that will create the Kubernetes cluster. This function will be called inside our main method, that is the test method, okay, where we do the Helm install and the Helm test. Okay, so this is the method 1, method 2, and this is the initiative. The very basic implementation will be this one. So method 1 will be called inside method 2 in automatic, creating the cluster and then instantiating the all the tests. Simple like this, okay? This is our first ambition today. So moving back to the terminal, we need then to start implementing our stuff. I told you before that, first of all, oops, oh, come on. Why I'm lagging behind so badly? Okay. We look safe. Come on. Oh. Sorry guys, I'll lagging a lot. Let me check the connection. Okay. Okay, so looks good again. Okay, we do need at this point, at least to get started, to implement a global variable here for our method that is the name of the instance that we want to use. Then in the Go SDK, you have a well-defined name for the function that you want to use for the automatic instantiation of your module, that is called new, where you can pass different kind of parameters. So you have new, in this case, no new, sorry, name and string, and then you want to pass demo SIGEX. You want to return a demo SIGEX. So this is the way you instantiate any kind of module. As far as I can tell, my test suggests that this is a cool way to do this. And so we are going simply, in this case, to return a demo SIGEX object with name, and that's all. So yeah, so here we are expanding. So this is a valid module, and we're going to implement our first method. And the first method that we are going to implement is, as I told you before, demo SIGEX, and this is a create cluster. So whatever you call and with the capital will be separated will be a command separated by a dash. So it will be a result in create dash cluster when you run your command line. But okay, so it's easier to see it in practice than talking about it. So then ctx, we need to pass a context usually, and context.context. Okay, cool. And then we want this to return a Dagger service. We are about to see what it's doing, so just trust me for the moment, and an error. Okay, cool. So now, yeah, is the magic. We installed the K3s module, so we can leverage that right away. We instantiate our service and error, just referring to that module. How we do that? With dag dot, and now you can see in the autocomplete string we have our instantiated K3s object. That is the one that you can find here in the Daggerverse. So we instantiate our K3s cluster just like in the documentation. So in this case, it will be K3s, and we pass a name. The name will be the one we set in the new function. So name. We call the server method of this module, and we start the service. So the start command for a service is simply saying, okay, as you see, start the service, check if it's okay, and return the service itself plus an error, if any. So, okay, now the only blame here is that error is not used. So if are different from nil, we are going to return nil and error. Okay. Oops. So of course. Okay. Cool. Otherwise, if there is no errors, our first module will end up simply like returning our service and nil as error. Come on. Okay. So many typos. Okay. So we are good. We have created our first method number one, that is the create cluster in here. And that's awesome, because now we can go ahead and test in practice. So what is the effect, first of all, that we get from this implementation? We can call Dagger co -h to understand all the parameters that we can pass for this module. It will take just a few seconds the first time we run, don't worry. Okay. More than a few seconds. Okay. So it's saying name is an option that you can pass for the instantiation, and that is required. And then there is the create cluster. This means that we can go ahead and say, okay, called name, and we can get test1. Then we can say create cluster -h again. Let's see what we can do with this service. With this Dagger service, we can do these kind of functions. We can get the endpoint, the host name, port, start, whatever. Since we are running start in automatic, we just need to do hub. Okay, so we want to, in this case, being able to bring up a Kubernetes cluster and forward that connection to our host. Cool. But if we forward only our host, our service to our host, so let me go back again here. So with this cluster, we instantiated something here. So here we have a service now that will be, you can imagine, like a forward port on 4.3 that is exposing your Kubernetes API server to the host. We miss another point, that is the kubeconfig, to be able to talk to this Kubernetes cluster. Of course, this is something that is very well expected, and in fact there is a method in the module that I propose to you today to do exactly this. So before going ahead with a complete test, let me just implement the other method that we need. So it will be a method again with that is demo sigx, and will be local config, simple like this. Okay, config ctx, that is again a context, and return this time a file, a Dagger file, and that's all. I think, yeah, that's all. Oops. Okay, so return a Dagger file, and the return will be simple like. Again, we are not doing anything other than applying the method that we get from the module of K3s. That's very cool. Oh, just in a second, we're going to put our effort in doing something original. We are not using that for free or without customization. We need to customize that. Don't worry. So, okay, we take the cache layer from the same name, so we access the same configuration for the service we instantiated, and we get the config tuned with true, tuned for the access from the host, not from inside the Dagger runtime. Okay, so config K3s config true. All right. Come on. Okay. So let me make this bigger and split horizontally and go here. Okay, so create cluster hub. Now Dagger will take care of running the Dagger module for K3s, start the service, and expose the Kubernetes cluster just for our fun, let's say, just to see how cool is this tool. And then from this other session here, we can start typing Dagger call --, name test1. So we access the very same session, but we call config method. And config method, if we do a -h, let me bring this to full screen, will tell us how to treat a Dagger file. So we can say, okay, export this file, and we say export -h. We also see that we can specify the path where to export this file. So we are going to export the file returned by config into --path kubeconfig.yaml. Okay, so if we do this, you see now the tunnel is up and running. So this session here is running the tunnel, the Dagger function to instantiate the cluster, and this other window in here is accessing the very same cache layer where the kubeconfig file is stored, apply some set to adapt to the fact that we are now accessing it from a tunnel, and it returns true. Turns true meaning that we have now here a completely valid kubeconfig file. And in fact, if we use kubeconfig and var, you are now able to access that Okay, so it's responding, it's running, and this is our Dagger K3s cluster. Okay, so first point number 1 is done. We can create cluster using the module. Now let's see how we can integrate all this stuff to do what we need. So instantiating our Helm chart on this cluster and test it at the same time. Okay, so that should be easy, right? So we stop the service now and we start a new method. You start understanding how it works, right? So the sci gigs, and we can call it test. And the test again will be a bit trickier, right? Because we need, of course, the context. It's always good to bring with you. Right. Then we need to bring in our folder. By default, Dagger runtime doesn't share any folder, any of your local folder. You can decide to bring into, at least in this version, you can decide to bring in whatever folder you want to, passing the path to the call function. And to do that, you need to put as a parameter of this method a directory variable. So we are going to charts folder, and we're going to pass a directory type. Okay, cool. And then from here we want to return a container. We'll see in a minute why this is useful. I suggest you to start every time with a container because it allows you to enter in an interactive session, understand what is working, what not, and whenever ready, you can always call it and make it executed in one go. But if anything goes wrong, you can spawn a terminal inside and see what happens. So we are returning a container, sorry. And again, you have different choice. If you go for pure test environment where you want to spawn everything with one call. One thing that you can do is taking the method above and do everything inside here. So we are going to import am dot create cluster. We pass here the am name. No, sorry. Pass here the ctx. Okay, and that's all. So now you do what we did before manually. So if you call test, inside test it will be instantiated the cluster. And this is fine if you want to make simple tests, but if you want to make more complicated stuff and you want to chain stuff, chain methods, there are different ways to do that. And I hope we are in time to, probably we are in time to show you both cases. Cool. So R different from nil. We go ahead and return a nil container with R. Oh, come on. Okay. Then we get also, we store somewhere a kubeconfig file because we want to mount this file into a container of ours where we have instantiated the Helm command line and all our charts. So we need to create a container, and we start from a kubectl container where we mount the kubeconfig file, and we mount also our charts folder. So let's start with the kubeconfig. It's dag.k3s m.name .config, and then since this will be executed inside the Dagger runtime, we need to pass false inside config because it's not anymore through the tunnel. Everything is internal. So, all right, I miss. Okay. So, expected one. Oops. Of course, return. And okay. Now we are ready to return our container. What we can do, so we can start from something, and this something, I save it here one side because it would be so much error prone that we can stay here forever. So Dagger container, this is the syntax to start from an image stored somewhere in a registry. So dag container and the name of the image. And then from this image, we start customizing stuff. So for instance, we can change the user if we want to install something. So we can go with user root. Okay. Then we can go ahead and with mounted file, we mount immediately our kubeconfig file, and for this image it will be stored in kubeconfig, and the name will be our kubeconfig file. Okay. Then there are permission stuff. Of course, you want to do not run any container as root, that's fine, but you need to then change the mounted file permissions. So we put this to the default user of the image above, telling that this command should be run without entry point, right? This is the meaning of this line. And on the same line, we can apply any kind of with exec command. And in particular, we need the followings. Let me again just copy paste because it will be too long to type. So we instantiating curl, we do have apt update and install, and then you have also the get elm to install the command line. Okay, we go back then to the default user, and we want to mount the charts folder. And how you can do that? You do that in this way. You change user again to 1001, and you do with directory /charts. And here, if you remember, charts folder is the directory that you pass in input. Cool. Now we have all the command line we need. We have kubeconfig installed. We have the charts folder available. We go ahead and install our tool, our awesome tool. And to do that, again with exec bash -c and the command that you usually we run. So test, we call the release test, and then we say, okay, it's in charts awesome values. You see here that in principle you can add another option here where you pass also the values file, a type file, you mount it inside the container, and you pass here the path where you mount values. So this is an exercise I'll let you do at home if you wish. Okay, good. So now there are a few things that we want to take a look at before editing further this. And one thing is that, of course, we need here to pass nil as error. And hopefully, yeah, we have no error. So we can go ahead, resume our command line, and instead of typing create cluster, we need just, since we integrated the method into the method, we just need, okay, I'll change the name, test -h. That will tell us all the needed parameters and what we can do with the outcome. Remember, the outcome is a pointer to a container, okay? Container type. Yeah. This method is returning a container and an error. Hopefully just a container. So, all right, so you see that Dagger test takes an argument, and the argument is charts folder. So -charts folder in our case will be charts. And then you can do a lot of stuff with container. And what we are going to do right now is the debugging thing that I suggested before. So we are going to attach our session to the container that is running. So we are going to go and say, okay, do all your stuff and then launch a container. So what it's going to do in this case, it's going to create a Kubernetes cluster. Let's go back. Let's go back to our method here. First of all, it's going to create a Kubernetes cluster with a K3s module. Then it will store kubeconfig and launch a container, a utility container for us that will mount the kubeconfig, the charts folder that we indicated, and then all the nitty-gritty detail to set up everything from the perspective of the command line that we need, and eventually installing the release, our chars, with the default values. Okay, the default values, just for information, is a simple nginx pod that it will run and return 200 for test. Okay, so let's go back and done. Now you see here we have our terminal inside our container, and if we do kubectl get pod, you see that our test awesome is working. We have also command line available telling us that the test release is deployed with a chart that we passed. We can do them. For instance, here now you want to do all kind of tests of your application. Our easy way to do this is, okay, test our test release, so elm test, and this will run a pod checking and trying to contact the instantiated service, and eventually exiting with a succeeded. Cool. Again, we can automatize this. Okay, so you can imagine now how this works. We can extend our test method with an extra step, and the extra step will be take this similar line in here, remove the point here, and then go inside here, select everything, oops, and start with a sleep for waiting a bit for the Elm chart to be installed. So sleep 30, let's say. You can do a smarter way, you can put some script and then importing it, but okay, let's wait and sleep 30 seconds and then drop the command that we tested before interactively. So Elm test. Okay, cool. So now can go ahead, for nil, and we have, at least on our laptop now, we are able to do the following. Very same command, but instead of terminal, we can make Dagger execute the whole test. Okay, so exiting with 0 or not, depending on the exit code of our Elm test command. So you can imagine that a bit more complicated. Of course, in real life, you want something like this, a command that every developer can run before creating a pull request. What we are going to do now is apply the very same test, reproduce the very same test in a GitHub action. So in this way, what the developer will run is exactly what the checks in the pipeline will be executed on your automatic continuous integration system, whatever it is. And yeah, not only that, you also have, as I showed you before, a very simple method to get started. You produce a module for your software, and people can start deploying and logging into functional workstation, functional environment pretty easily. So just appending terminal instead of std out, and you're ready to go basically. So yeah, I think this is pretty fun. So let me, okay, so you see now the output is exactly as before, and everything exited successfully, and we are happy. We are happy, but we might miss an important stuff. We might miss the part that allow us to reproduce this in a GitHub action. And to do that, the last one thing I want to share with you. Well, almost the last thing I want to share with you today is creating a make the -p -p GitHub workflows and then mv.github workflows. So we are going to implement workflows, right? ci.yaml. So we are going to create our CI for GitHub, simple like this. So we give it a name that can be integration tests. Then we execute this on push, okay, on commits, whatever, course branches. For now, we can execute it on main, okay, and then, okay, I'm going to copy because it's a bit too long. We have for GitHub action a dedicated action already available for executing any kind of Dagger workflow. So just take a look here how it works. So you check out your code, and then you say, okay, I want to execute a command that is call with these parameters, right? So name test chars stdout. Cloud token, if you want to use Dagger Cloud, that is another topic that we won't touch today. You can pass the token here, and then you have the version for the Dagger engine. That's all, simple like this. If you have a command that a developer can run on his laptop, you can bring it here and execute the very same on your GitHub workflow. So without losing too much time, the result will be that if my command succeed locally, what you will get, this is the repository left for that I prepared before. If this succeeds, the action itself will succeed as well. So you don't have okay. Okay. So yeah, hello Soledam. I see your message. Just a second, I come to you very quickly. So okay. Okay. I hope everything is working. If anything, anyone is following, are you still able to hear me? Because I see a pretty old replay on my screen. Okay, let's hope for the best. So I was saying, here is the build, and the integration test that we set is in here. Again, succeed, very same output, everything in line. So you have now a functioning pipeline that is working wherever you want. Yeah, I can tell you that this is helping a lot to get the best out of your pipelines. So having a lot of green interaction, that is always good. Having your developer able to get started very soon. So yeah, so far so good. I think I had so far a very good experience, and I hope this will help you also understanding a bit and getting started with what you need for your use case. If you have anything that you want to propose, or you have some concept or that is not clear, or use case they want to bring in, yeah, please feel free to to drop a message or a comment if you see this recorded. npm ci main.go, just to take a look at the different endpoints, different, let's say, way to integrate methods. And in particular, I'm talking about chaining function. Chaining function means that, for instance, I can do something like this. So I can return, instead of a service, I can return a demo SciGeeks object, right? And if in demo SciGeeks object I put a service, I put a service cube svc, that is a service. Okay, I can do the following. Here I can return an object that is demo SciGeeks. No, sorry, can return m and m dot cube cvc. Okay, so without doing the start ctx. Okay, so I'm feeling this means that this will be a method that by itself won't do anything. We'll just prepare the field for something else. For instance, now here I won't need to do this, but I will instead do this one. I will call svc from the global variable, and I will rather start it here. Okay, what are the benefits of this approach? Well, svc, okay. So what are the benefits of this approach is that now, okay, I mistyped the folder, sorry. Now what we can do is use this kind of syntax. So we instantiate name test2, we create a cluster, and then we execute test. This is particularly useful because now create cluster is a generic method that you can compose with other methods other than test. So it's a different approach. It is not executing one inside the other, but you know, it depends. It's partly is matter of taste, but partly is also depending on what you want to do with this tool. If you want to get a tool, a generic tool both for test and development, chaining is a very good way to achieve this. So if we now run this, if I haven't break anything, now everything should run just like before, but with a different approach. So it's starting the Kubernetes cluster, and come on, and it's running the test. So it's sleeping 30 seconds. Hopefully, yeah, 27, 30, 31. Okay, the pod is initiated, and now we are ready to go. Cool. So very same kind of stuff, but with the chaining method. I hope that will help other people to get started with this kind of approach. Very, very, very easy. As you can see, you can integrate any kind of workflow, bringing up Kubernetes cluster in the same manner as you would do in a GitHub Actions. Thank you very much, guys, and see you next time.